This is a Sensor Solutions video demonstrating residual magnetism of some of our sensor housings. We have a couple of sensor housings that have been machined out of a 303 stainless steel. This is just a neodymium magnet, a standard magnet, about 3/8 inch diameter, and if you put it up against the face of one of our sensor housings, you can see there's a little bit of attraction to it, but certainly it doesn't stick to the face. This is an example of a housing that was machined out of the wrong material completely, and you can see pretty substantially different. Can't even get the magnet off of it. Then this is a longer sensor housing that's been machined. The back was machined pretty heavily. It has some threads on the inside, a knurling process. The front was threads, solid face, and using just the neodymium magnet, you can see that there's almost no attraction to the sensor face. I can get a little bit, but almost none. But if I go back to the back of the same piece where it's been machined pretty strong, you can see there's a pretty substantial attraction where this has been machined a lot more. This is perfectly fine. What we do is we pot a magnet inside the face, so this face of the part is the part that we're worried about. We're really not worried about how much magnetism is on the back of it. Then, just to get a little bit more high tech about this, we have a analog sensor meter, where we have one of our potted sensors that has a magnet inside of it, and the analog output is proportional to how much attraction there is to this magnet, kind of like an electronic version of what we just showed. So if I just take a piece of steel like this plate, steel gang plate, if you look at the analog voltage zeroed from the sensor, as I bring it closer to the piece of steel, analog voltage actually goes all the way up to 4 volts. As I back it away from the steel, it drops. So it's proportional to distance between the plate and the sensor tip. If I take that analog sensor and put it up against our sensor that we liked, go up to the face, you can see it's going to increase it to 20 or 30 millivolts as I'm touching that sensor face. Goes to 0 with nothing. If I go up to the part that's been machined hot or something that made it become much more magnetic, you can see that that's increasing 50, half a volt, almost 3/4 of a volt. So there's quite a bit more magnetism in the back of this housing than the front, as we said, and this little tool can tell us how much magnetism has been done to the part when it was machined. So on this housing, which we really liked, we're seeing about 50 millivolts, 0.05, 60 millivolts of output, proportional to just touching the face. If we go up to the sensor that we didn't like, that was made out of the wrong kind of steel or something happened to it, you can see it's completely attracted and it goes all the way up to 4 volts.